is going to cover binary and hexadecimal numbers. Numbers in different bases. Normal numbers are in base 10. So the numbers in one place go from 0 to 9, and once you reach 10, you move over to the next one. Binary is 2. So the numbers in one place go from 0 to 1, and once you reach 2, you move over to the next one. Hexadecimal is base 16. The numbers in one place go from 0 to 15, and once you reach 16, you move over to the next one. Once you reach 10, the numbers get converted into letters. So 10 becomes A, and 11 becomes B, etc. All the way to 15 becoming F. And this is because in a hexadecimal number, it's only one digit per place. And so once you reach 10, you have to have some way to represent it with only a single digit. Places. Places for binary. So the base for a number determines what the starting point for the places are, and the different places are just the different powers of that starting point. So since binary is base 2, its places are 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, and so on. And the powers just keep going up as you move towards the larger numbers to the left. So binary doesn't have a tens place or a hundreds place. It has a twos place and a fours place, and so on. The places for hexadecimal, or hex. Since hex is base 16, the places are 16 to the 0, 16 to the first, 16 squared, 16 cubed, 16 to the fourth, 16 to the fifth, and again, the powers just keep going up as you move towards larger numbers. And hex doesn't have a tens place or a hundreds place. Instead, it has a 16s place and a 256 place. And those will continue to go up much, much more quickly than binary does because they're powers of 16 instead of powers of 2. Converting between bases. So to go from base 10 to binary, you divide the original number by 2 repeatedly, along the way keeping track of the remainder of the division and prepending it to a binary number that you're going to build up along the way. And you continue to divide until the answer is 0. So here's an example. We're going to start with 34. And 34 divided by 2 is 17 plus 0. So that'll give us a 0 here. And then 17 divided by 2 is 8 plus 1. So the next number on the left is a 1. 8 divided by 2 is 4 plus 0. So we're going to get a 0 for the next digit. 4 divided by 2 is 2 plus 0. So we're going to get another 0 on the left. 2 divided by 2 is 1 plus 0. So another 0 here. And then 1 divided by 2 is 0 plus 1. So the final digit on the left is a 1. And if we look at this column of remainders, the answer is in binary if you go from the bottom up. So 1, 0, 0, 0, 1, 0. From binary to base 10. So for that, you look at each place in the binary number and add together the correct power of 2 for the places that have 1s in them. So if we're going to start with this binary number, and these are the different places for each spot, and then we're only going to look at the places that have 1s in them. So 2 to the 6th, or 64, 2 to the 3rd, 8, 2 squared, 4, and then 2 to the 0, which is 1. Any number to the 0 is just 1. And then we're going to add them together to get 77. And that's the answer in base 10. Base 10 to hex. For this, it's going to be the same process as with binary, except with 16. So we're going to repeatedly divide the original number by 16, along the way keeping track of the remainder and prepending it to a hex number we're building up. And again, you continue to divide by 16 until the answer is 0. And remember, numbers over 9 become letters. So 10 will become A, 11 B, 12 C, etc. Base 10 to hex. So this is a demo. We're going to start with this original base 10 number, 5,950,337. So 5,915,337 divided by 16 is 369,708 plus 9. So the first digit over here is going to be a 9. And then 369,708 divided by 16 is going to be 23,106 plus C. So the next digit is C on the left. 23,106 divided by 16 is 1,444 plus 2, so 2 next. 1,444 divided by 16 is 90 plus 4, so 4 is going to go on the left. 90 divided by 16 is 5 plus A, so A goes on the left. And then 5 divided by 16 is 0 plus 5, so 5 is the final digit, and we know to stop because the answer was 0 when we divided. And again, this column of remainders is the answer if you go from the bottom up. So 5A, 4, 2, C, 9, which is this answer. Hex to base 10. So for this one, you look at each place in the hex number and multiply by the correct power of 16 for that place, and then add together the results of all those multiplications. So if we start with the same hex number that we just calculated on the previous example, and we look at the powers for those positions from 16 to the 0 all the way up to 16 to the 5th, and then we get the answers for those multiplications, and I'll add them all together. We'll get back that original base 10 number of 5,915,337. And that's the answer in base 10. Binary to hex. So for this, you're going to split the binary number into sets of 4 bits each, because 4 bits in binary is 1 digit in hex, and then convert each set into base 10, and then from base 10 into hex, and each should be a single hex digit, and all of those hex digits together will form the final hex number. So this is our original binary number, and we're going to split it into groups of 4 bits. And you'll see that it's padded at the front here with zeros to make the number of bits divisible by 4. So this is 9, since 8 plus 1 is 9. This is 12, since 8 plus 4 is 12. 2, since the only 1 is in the 2's place. 4, since the only 1 is in the 4's place. 10, because 8 plus 2. And 5 from 4 plus 1. So now we're going to convert these into hex, and anything below 10 stays the same. So the 9 will stay the same, 12 becomes C, 2 stays the same, 4 stays the same, 10 becomes A, and 5 stays the same. And then you just squish it together to get back the hex. Okay? And then from hex to binary, you convert each digit in the hex number to base 10 separately, and then into binary, padding to 4 bits when necessary. And then you put all those sets of 4 bits together to form the final binary number. So it's just the exact opposite of what we just did to convert from binary into hex. So we're going to start with this hex number and split apart each digit to look at it separately, and then convert them to base 10. So 9 becomes 9 because everything below 10 stays the same. C becomes 12. 2 stays the same. 4 stays the same. A becomes 10. 5 stays the same. And now we're going to convert each one into binary. So this is the binary for 9, the binary for 12, binary for 2, and this got padded with extra zeros to make it be 4 digits fully. 4, and then 10, and then 5. So altogether, that's the answer in binary. And that's it. Binary and hex are used for low-level computing things, so you won't generally have to see them when you're dealing with a higher level language like Java, but they're nice to know for what's going on under the hood for programming. And that's it.